Okay, the power rule. The power rule in calculus basically lets you find the derivative of a function, okay, rather quickly versus having to do the difference quotient and taking the limit as h approaches 0. Okay, so the power rule, first of all, needs to be in the correct form. Okay, so you have a constant times a variable, usually x, alright, and sometimes you have exponents, okay? So what happens is, what the power rule says is you will, to find the derivative of y here, so let's say y prime is equal to, you multiply the exponent with the coefficient of x, so this constant right here, so we end up with 20 x, and then whatever the exponent is, you subtract 1 from it. So we minus 1, 4 minus 1 gives you 3, and that's the derivative. Very, really quick. I guarantee you, if you were to use this function, plug it into the difference quotient, and take the limit as h approaches 0, you would get the exact same answer. Okay. Over here, say we need to take, we're gonna find the derivative of y with respect to x. So we multiply, that gives us negative 6x, and if we subtract 1, that's going to make that negative 4, so be careful there. Right? So here's our derivative. Now usually they'll write it so that the exponents aren't negative, so this is the equivalent to negative 6 over x to the 4th. Okay? Real simple. Let's try some, okay, let's take a look at another example. Let's say we have y is equal to 1 over 2x to the 5th. This is equivalent to 1 half x to the negative 5th. Right? So now we're going to take the derivative. Y prime is going to equal, so negative 5 times 1 half, right? That'll give us negative 5 over 2x. Then remember, you subtract 1, so you can end up with negative 6. So this is our derivative. Okay? Really simple, real easy. Take a look at a few more. How about we have pi over x to the second. Well, let's say y is equal to. Well, this is equivalent to pi times x to the negative second, correct? So if we're going to take the derivative of this, y prime is going to equal negative 2 times pi. We have negative 2 pi, right, x, and then we subtract minus 1, so that gives us negative 3 as our exponent. And if you want to write this without negative exponents, it would be negative 2 pi over x to the third, right, y prime. Right. Same thing up here, if you want to write it without negative exponents, this would be negative 5 over 2x to the 6. Alright, as the x to the 6, negative 6, gets moved to the denominator. 6 becomes positive. Let's try a couple more. Still going with a radical. How about 1 over 3 radical x? Okay. Well, this is equivalent to, so say we have y is equal to, this is equivalent to, let's change this to x to the 1 half, and then we move it to the top, x to the negative 1 half, right, over 3, or you could write this the same thing as 1/3 x to the negative 1 half, okay? Both these mean the same thing, right? So now if we're going to take the derivative, right, derivative of y with respect to x, so when we take negative 1 half times 1/3, that's going to give us negative 1 over 6, right, x, and negative 1 half minus 1, so basically you have negative 1, right, and a half here, right, which is going to be negative 3 over 2. And if you want to write it without negative exponents, that's going to make that negative 1 over 6 x to the 3/2 power, right? And if you're going to change this, right, and you can leave like this or change it to radicals, really up to you. Okay. Now, say we have y is equal to 3x to the 9th power minus x to the negative 3rd. Okay? So to find the derivative of this, all right, we can use the power rule. Basically, we can use the power rule with, breaking apart addition and subtraction. That's fine. So basically, we can take the derivative of this and the derivative of this separately, and it's perfectly fine. Okay? So let's say y prime is equal to the derivative of this, which would be 27x to the 8th minus, all right, and here's where you have to be careful. You have a minus, and when you multiply here, you get a negative 3, right? Pretend there's like a 1 here. It gives you negative 3x to the, when you subtract 1, you get negative 4. So a negative is going to make this positive. So y prime is going to equal 27x to the 8th plus 3x to the negative 4th. And if you want to write this without negative exponents, it would just be y prime is equal to 27x to the 8th plus 3 over x to the 4th. Okay? Really simple, nothing complicated about it. Let's take a look at another one. So power rule is actually really easy, and for sure it's a lot easier than difference quotient elements. Alright. Say we need to find the derivative of 4 minus 3 radical x. Okay? So the derivative of y with respect to x is equal to, now the derivative of a constant, you have to remember, is always 0. The derivative of a constant is 0. Over here, let's change this. If we had converted this to negative 3x to the 1/2, so we would end up with 1/2 times negative 3. That will give us negative 3 over 2x. Now 1/2 minus 1, right? If you minus 1, that's the same thing as subtracting 2 over 2. So that will leave you with negative 1/2. And if you want to write this without negative exponents, right, so our derivative is going to equal negative 3 over 2, right, x to the 1/2 power. And if it's up to you, you can change that to a radical. This is equivalent to negative 3 over 2 rad x. Right, these two mean the same thing. Okay? So this is to a few more. We throw in some polynomials. Say we have y is equal to 5x to the 8th minus 4x squared plus 2x minus 10. If you were to take the derivative of this, right, y prime is going to equal, so right here we have negative, sorry, not negative, multiply here, we get positive 40x to the 7th, right? Multiply 40, subtract 1 from the exponent, and we have negative 8x to the 1st. This will give us just plus 2, and the derivative of a constant is 0. So here is our derivative. And keep in mind, while you're doing all this, when you find the derivative, what did you just find here? This is the slope, right, formula, right, slope formula of the tangent line, okay, to this curve, right, to this curve, right. So to find the slope, right, of the tangent line to this curve, it's this formula right here, which is the derivative, okay, which is the derivative. So don't ever forget what you're finding. When you get that answer, when you get the derivative, always remember what you've just found. It's the slope formula, right, of the tangent line to the original function. Okay. So let's take a look at an example. So let's look at another example at what points does y equal x to the 3rd minus 3x plus 4 have horizontal tangent lines? So let's understand the question. So here's a curve, right? We want to know at what points, right, are there horizontal tangent lines to this curve? Okay, so we're talking about tangent lines. That means we need to find the slope, right? Slope is the derivative. So what is the derivative of this function? So we're going to find y prime. And then let's use the power rule. We'll end up with 3x squared minus 3, right? So remember this right here, when you find the derivative, this is the slope formula, okay? This is the formula to find the slope of the tangent line, okay? Now, we want the tangent lines to be horizontal. That's important information because if you have a graph, if you recall, if you have a graph, right? If the line is horizontal, we know the slope is equal to 0. Now, since the derivative is the slope formula of a tangent line, we are going to take the slope formula and find out, hey, when is this going to equal 0? What values of x will make this 0? So let's factor out the 3. X squared minus 1 is equal to 0. So we factor x plus 1, x minus 1. So we get x is equal to 1, x is equal to negative 1. Okay, so negative 1 and 1 makes this 0. Now the question though was, at what points, right? So we need to find coordinates. To find the coordinates, right, you're going to take x, because all you have is x. To find out what y is going to be, you have to take x and you plug it into the original, okay, into the original function. So y is equal to, in this case, 1 to the third power minus 3 times 1 plus 4. So you end up with 1 minus 3 plus 4. Alright, and then that's going to give you 2. Alright. And over here, when x is negative 1, we're going to plug negative 1 into the original function. We get y is equal to negative 1 to the third minus 3 times negative 1 plus 4. We end up with negative 1 plus 3 plus 4. Okay, so that gives us 6. So at these 2 points, right, there will be horizontal tangent lines to this curve. Okay, and you can always verify with your graphing calculator. So at these 2 points, there will be horizontal tangent lines to this curve. Horizontal tangent lines meaning there will be, basically just horizontal, lines to this curve right here, and the slopes of the horizontal lines are 0. Okay. Okay, let's take a look at another example. Let's see how y is equal to the quantity 3x squared to the 4th. Okay. Now, when you have something like this, you have to be careful, right? You cannot use the power rule right now exactly the way it is because it's not in the right format. Okay, it's not in the right format. What you have to do is, this is basically a composition. Okay, this is composition. Later on, you'll learn something called the chain rule that you'll use with this, right? But you can't use the power rule, right, when the problem is like this. What you have to do is you have to distribute this exponent first, so that you end up with basically 3 to the 4th power, right? And then x to the 8th. So 3 to the 4th is 81, x to the 8th, right? So you have y is equal to 81x to the 8th. Now you can, it's okay to take, now you can take the derivative of this, alright, the derivative of this, okay? So you can't have the power of powers, okay? This is considered a composition. So you have to and if you have something like this, you have to distribute the exponent first, and then simplify, and then what you get, you can take the derivative of this, okay? So let's take the derivative of this now. So we're going to end up with y prime is equal to 81 times 8. I believe that gives us 81 times 8, that's 648. X, subtract 1 exponent, alright, and then you get your answer, okay? Just remember though, if you, when it looks like this, you cannot do power rule, alright, when the function expression looks like this, okay? If you have to distribute this exponent in here, simplify this, and then you can use the power rule, okay?